First off, tell me about the proteins in that heterozygous individual. What would you expect? You'd expect it to be 50-50, to be extremely precise, 50-50 what and what? Exactly. It would be. That's exactly right. All right. So thank you, Lauren. Let me put that. Thank you. So you'd expect 50% normal and 50% Christchurch. That's sort of rule. That's rule 1 and rule 2. Both alleles do their thing, which means you get a mixture of both proteins. All right. So at the protein level, looking at what proteins are made, it looks codominant. You see both proteins made, and that's almost always true. Okay. The real big question is, it can't be codominant. You can't be both diseased and not diseased. You got to be either one or the other. And so the question is whether that person's going to be diseased or not. So let me call somebody. Let me give somebody some points for yelling that out. So Shun, are you here, Shun? Shun, so tell me, what's your take? Diseased or not? I got a not. Okay. I heard it. There was earlier a yes. All right. So then there's a yes. So Shun, tell me why not? Normal would be dominant because it's normal. It's clearly better. All right, cool. I'm down with that. Somebody who said it would be diseased. Why?
Because it's doing something different.
Okay. So the argument in favor of yes is that it's the mutant one is doing something different. What's the thing it's doing? It's making the hemolytic unit. It's making those Heinz bodies. So you got two opposing arguments. Normal being dominant. That's perfectly reasonable, right? It's normal. It should be functional, do its thing. On the other hand, you have the other argument which says the mutant one is actually doing something, and doing something is dominant. It's doing this bad thing, right? Yeah. So doing something is dominant. So it turns out that these guys are actually hemolytic anemia. All right. So, and I'll explain why that is in a second. But if they're hemolytic anemia, which allele is dominant, H or HC? HC is dominant. So in this case, this is going to be recessive, and this is going to be dominant, because that's what that means. So what's the deal? The Christchurch molecules still form Heinz bodies because they're folded wrong, even though the normal ones are there. That is the normal. So you got a mixture of normal and Christchurch. The normal can't fix the Christchurch. The Christchurch on their own do these bad things. They get sticky, they stick to each other, they form Heinz bodies, gums up the works, therefore hemolytic anemia. For this guy, for the heterozygote, therefore the disease phenotype is, disease phenotype of H big C is dominant. And that doing something, in this case, making Heinz bodies, is dominant. Right. Oops. Questions? Because I want to do another example. Yeah. Levi. Normal hemoglobins. I should say, let me take that. I can fix that. Normal hemoglobin, or yeah. Even though the normal says it's a 50-50 mix of normal and Christchurch, the normal ones can't fix the broken ones. Yeah. Would there be a difference in the severity of disease? That's a really good question. The answer is probably yes, although it sort of depends. So you might make an argument for incomplete dominance, maybe-ish. It depends on, basically, if you draw the line at sick or not sick, it's dominant. If you draw the line at degrees of sick, you might make a case for something else. But here we're just saying, are they sick or not, and they'll be sick. They might be sicker if they're HCHC. That's probably true. There's a reasonable case to be made for that. Yeah?
So basically, when it's mixed, the dominant is whatever's being produced. So like in cancer.
Let me leave this. Let me stick with the first part what you said. What it means to be dominant is when you mix them, the dominant one is the one that shows. Right? And so that's what dominant means. The cancer question is something we have to talk about later, but it's a good one. All right. I want to do another example to have people think about this through, because it can be, these things can be tricky. And it's actually, this is a very big and important point. Example 2, hemoglobin Woolwich. I forget. I think it's from England. And here, you got allele, beta globin produced, and then contribution to the phenotype. All right. And we'll do something very similar. We have a big H allele, and it's normal. And that is number 132 is affected this time, is lysine. And lysine can make, trust me, it can make H bonds and ionic bonds. Okay? And this is normal hemoglobin. We'll call HW Woolwich, so it makes hemoglobin Woolwich. And there, number 132 is glutamine, which basically makes H bonds only. Right? It's a little bit of a difference. In this case, hemoglobin is present. Actually, I should say it this way. Number 132 is on the surface of the protein. I won't have time to show you the structure, but if you could see it, it's up on the surface of the protein. Hemoglobin is present, and no Heinz bodies. No Heinz bodies form, but it doesn't bind oxygen well at all. So this is a more subtle mutation. The protein's not totally hosed. It's not totally screwed up, right? It's not misfolded and sticky, gums up the works. It just, for whatever reason, doesn't bind oxygen. It's not quite the right shape, doesn't quite do the right thing, doesn't bind oxygen. Maybe binds a little bit of oxygen, but not nearly as much as you need. So people with this stuff are going to be anemic as well. And so if we write up our genotype, beta globin produce, and phenotype, we're going to do the same drill. So big H, of course, is 100% normal, and that's normal. Big HW is 100% Woolwich, and these guys have anemia. Sort of regular anemia because of this. Right? And the big question is big H, big HW. So the same old thing. Talk to your neighbor. What proteins do you find? And what's the phenotype going to be? And let's, for the moment, just draw a line. They're either normal or they're anemic. We're not going to worry about degrees of anemia. You got it or you don't. So what I want to know is, what proteins do you find? And using the doing something as dominant rule, what do you think?